Okay, so now let's proceed to the first flowchart. Okay, on the left, this is the fan speed flowchart. In this flowchart, we can see the temperature senses any input. For example, if the temperature is lower than 29 degrees Celsius, the fan is off. When the temperature is equal to 30 degrees Celsius, the fan is 25% speed. Next is when the temperature is equal to 31 degrees Celsius, the fan is 50% speed, as well as the temperature input is 32 degrees Celsius, the fan is 75% speed. If the temperature is more than 32 degrees Celsius, the fan is 100% speed. Okay, let's proceed to the water pump flowchart. This flowchart shows that when the user sends on as an input, the pump will be on. If no input, the pump will be off. The third flowchart. The third is the LED on-off timer flowchart. In this flowchart, B brightness is key in by the user, which will be explained in the next flowchart. The input start time and stop time will be key in by the user desire of when they want to use it. And the get time now is the real time clock RTC getting the actual time. If the time now is equal to the start time, the LED will be on, as well as the time now is equal to the stop time, the LED will be off. And last but not least, the brightness input flowchart. For example, if the input from the user is equal to 1, the brightness is 25% speed. If the input from the user is equal to 2, the brightness is 50% speed. If the input from the user is equal to 3, the brightness is 75% speed. And the last one, if the input from the user is equal to 4, the brightness is 100%.
Now we will be looking at the coding itself in our Arduino IDE. So we start with including all the required Arduino library. So one wire.h, that is temperature, wire.h, this is all required for the DS18B20 temperature sensor. And this is required for the RTC as well as this. And Adafruit, GFX, this is for the graphic of the Adafruit. This is for the OLD. We are using the SSD1306 OLD, so we need to download this library. This is for the OLD reset, and expose 0, which means the X position of the OLD, the Y position of the OLD as well. And this is the height of our OLED, and this is the width of our OLD. So we are using the 128 multiplied by 32. And after that, we are going to define our one wire bus pin 13. This pin 13 is where our temperature is hooked in pin 13. So starting up everything, this display, starting up the RTC, we're using RTC 1307, initializing the days of the week from Sunday to Saturday in the char in array mode, and initializing the fan into pin 3. So we're using the pin 3 of the Arduino hooking up into the output of the fan. So we are going to create a new instance of one wire class to communicate. This is to communicate with the temperature sensor, as well as passing the reference to the Dallas temperature library. So setting up the void setup. In the void setup, as usual, we're going to use 9600 baud rate. We are going to check if the RTC is connected or not. So this is the code for checking it. If cannot find, then we print could not find RTC. So we're going to start the RTC right over here, and in order to adjust the time to the current time, you just need to delete this. This is the code for adjusting time of the RTC according to our computer time, but I already did that, so we don't need to do that. So we're gonna start by turning off the pump at the very beginning. So analog right, the pump is hooked up with pin 5 and start with 0. And beginning the sensor and display the Arduino in the display the Adafruit in the OLD as mentioned by the Adafruit company. You need to display it. So we display that. So now we will be talking on how the sensor, we'll be able to get the data and then put it inside the Arduino in order to adjust it according to the fan speed that we desire. So first we're going to request the temperature for the sensor and then put it into the integer, so temp C for Celsius and temp F for Fahrenheit. So put it inside the integer, and I'm going to print that inside our serial monitor right over here. So looking at the code of how the temperature value will be used in order to control our fan speed. So for example, if our temperature C is less than 30 degrees Celsius, the fan will be turned off. So analog right fan 0, which means the fan is off is because because the temperature is low. And then subsequently, if the temperature C is 30, we're going to put it in as 30%. If the temperature is 31, we're going to put it in 50%, and 32, we're going to put it into 78%. And if it's more than 32, for example, it's 33 and above, it's too hot, we're going to put it into the maximum value. And of course, we can adjust the value of the temperature here. 30, 31 can adjust to our liking, but this is the room temperature, so I'll be just using that for now. And we can also adjust the duty cycle of our fan speed, so we can adjust 50% here, 75 probably, this is 90%. So yeah. So now we will be talking on how to control the brightness of the LED. So here the pin 5 is our LED. The function is similar with the fan, which is we're going to use the analog right. So if max, we're going to put in 255 the maximum value, and if it's 0, then we're going to put it to turn off, to put 0 to turn off. So this is just for the sake of knowing how the function going to work. The value here 255, 125, 75 and 25 depends on the GUI from the user. So as we mentioned in the flowchart before, so now in order to get the RTC time from the RTC, we're going to use this function date time now, rtc.now. So we're going to print the year, the month and the day, as well as the hour, the minute and the second onto our serial monitor. So this is the function to print on our serial monitor. So in this part, I will show you how we are going to use the data from the RTC in order to be able to give the user the opportunity to control when they want to on and when they want to off the LED. So here function is now.second, but in the real application later, we're gonna use now.hour because we're not gonna wait for 1 hour just to see if the code is right. So we're gonna use second instead. So if the second is hit 30, the LED will on, and if second is hit 40, the LED will off. So this is how we are going to use the data from the RTC. So for example, user will be able to use to turn on the LED from 8 to 12, or from 8 to 3 in the evening, and so on. And moving forward to the turn on and off of the water pump. So in order to turn off, you just put this value over here, analog right, pin 7 is hooked to the water pump. And just to show how we are going to on and off, we use this function over here, and yeah, you're just gonna delete this, and I'm gonna show in the video also. For the LED, first of all, there's just one important thing to mention here, which is to turn all the value from the RTC, now.hour, now.minute, and from the value from the temperature into a string, so that we'll be able to print on our OLED. So this is the function of printing into the OLED. So this is for the temperature, this is for the time, and this is for the date. So yeah, this is basically the main function of how are we going to use our OLED. Last but not least is just a function for our OLED text. So this coding here is just to show that the hardware is going to function. Of course, this is not our finalized coding, as we will still need to implement the GUI into this coding. So after we have the GUI, this coding will be a bit different, but this is basically the foundation of it. So that's it for our video, that's it for our milestone. We're gonna see you again in milestone 2B, and happy Chinese New Year.